This is a question that also involves exponential decay, an exponential model. So we've got the half-life of carbon-14 is known to be 5,700 years. Find a formula for R of T, where T is in years. So we've got to find out how much of carbon-14 is present at any time T. From knowledge we've done, we know that our exponential growth, if it was growth, so we'd have RT equals R0e to the kt, so that is my growth model for exponentials, and the decay one is R of t equals R0e to the minus kt, and that is decay, exponential decay. So your first dilemma, if you like, is to make up your mind whether we've got a growth problem here or a decay problem. And it's obvious if you've got the half-life, that means it takes 5,700 years for half of the initial amount to be present. So we're going to have here a decay problem. So we're going to use that as our model. So we've got RT equals R0e to the minus kt, and we then are asked to try and find values for these. So the first thing to do is, so we know that the half-life is 5,700 years. So we've got, and R of t will be equal to 0.5 of R0. So that's how much will be present after 5,700 years. So we've got 0.5 R0 equals R0 e to the minus k. Now the t value is time in years, so 5,700 years. Now we've got two unknowns here. We've got k and R0, but it's quite easy now to divide both sides by R0, and that will cancel both of those out and you get 0.5 equals e to minus, now probably we should put the number before the prime numeral, so we'll put minus 5,700 years k. Already we've looked at a technique for solving when you've got e we know, but we've got the unknown k, which is in the power, is to take logs, and because we've got e, we'll take logs to both e. So take, now instead of writing ln, natural log, I'll use the other way of writing it, this question, just get used to both of them. So log to base e, so we do that to both sides. 0.5 equals log to base e, e to the minus 5,700 k. And bear in mind the equations are like sets of scales. Whatever you do to one side, if you want it to balance, whatever you do to one side, you've got to do to the other side to make sure it balances. So if we take log to base e of this side, we've got to do it to the other side as well. We've seen from properties of logarithms that this power now can come out the front. So it'll be minus 5,700 k, and we're left with log e to base e. Now a logarithm is a power. So what is the power you must raise e to get the number e? Well, that must be equal to 1. So log e to base e is equal to 1. The power that you've got to raise e to get e is 1. So we're left with that equals log base e of 0.5. Get k by itself now is log e 0.5 all over negative 5,700, and we'll get k is equal to 0.00012. So that is my k value. Be very careful with that. This is the model that we're working on. So we've got R of t equals R0 e to the minus, now the k value, don't forget it's e to the minus k. Now we've worked out that k is equal to that, 0.00012 t. So that's my formula. So we've done part A, find a formula for R of t in terms of t. Now the second part of the question says that a fossilised tree is found to be that. How long has the tree been dead if R0? So we're given R0, and how long means we're going to actually calculate t. So I'll just move down the page a little bit here. So this is part B. We'll start with our formula here, and we're asked to find how long it has been dead if R0 is equal to that and R of t is equal to that. So instead of R of t, we can write 1.17 times 10 to the minus 12 equals R0, 1.3 times 10 to the minus 12, e to the minus 0.00012 t. Okay, what have we got here? E is the exponential number, so that is not an unknown. We know what that is. So we've only got one unknown here. So it'll probably be good to take logs, but before we do that, should take this to the other side. So we've got 1.17 times 10 to the minus 12, dividing both sides by 1.3 times 10 to the minus 12, so 1.3 times 10 to the minus 12 equals e to the minus 0.00012 t. We can cancel these. They'll go into each other once. And so we've just got that. The unknown is t, and it is in a power, so we take logs. So take ln, or log to base e, either way. So we got ln of 1.17 over 1.3 equals ln of e to the minus 0.00012 t. Bring that round down to the front, minus 0.00012 t. Log e, log to base e of e is just equal to 1, equals ln 1.17 over 1.3. T is equal to ln 1.17 over 1.3 all over negative 0.00012 will be equal to t, and putting that in your calculator and working through very carefully using brackets there. You may have to put a bracket around the whole lot there as well when you put that in your calculator, and then divide by that, we'll get 878 years.